7.4 Demand and isoprofit curves for beautiful cars. In the previous video, I talked about the cost structure of this company. In this video, I'm going to talk about the demand side and profit. So for the demand curve, we got a typical downward sloping line. As the price of beautiful cars drop, the demand for them go up. A very familiar, straightforward demand curve. Now let's scroll down and talk about isoprofit curves. Let's start with the situation that our company makes no profit at all. That can happen when the price that they're charging for their car is the same as the average cost of production. Therefore, the average cost curve here that we introduced from our previous video represents a case where our firm makes no profit at all. But if Beautiful Cars starts to charge a price that is higher than the average cost, a price that is higher than the unit cost, the company starts to make profit. And that is represented by these other isoprofit curves. Now, this isoprofit curve represents a scenario where our firm makes a total profit of $70,000 per day. This other curve represents a scenario where our company makes $150,000 of profit per day. Now, let's introduce our marginal cost and think about a specific scenario. In this scenario, our firm produces a small number of cars but makes a lot of profit on each car that it's selling. And that scenario is G. In this case, the company is pricing each car around $7,000, but each car is costing the company around $4,000 to produce. So the company is making a lot of profit on each car that is selling. And in total, it makes a profit of $70,000 per day. Now, we can think of another strategy that the company can follow and make a same amount of profit per day. And that strategy is K. In that strategy, the company produces a higher number of cars, but makes a smaller profit on each car that is selling. And that's represented by a smaller gap between the price and the average cost curve. Now we can think about another scenario again. H, for instance, our company still produces a higher number of cars but charges a higher price and therefore makes a higher profit, makes a total profit of $150,000 per day. Now, remember that all these isoprofit curves are hypothetical. They exist in the entrepreneur's mind. Remember, they're like indifference curves. They were hypothetical as well. They introduced them in the unit tree. They existed in people's mind. This is also the same with isoprofit curves. They are inside the entrepreneur's head. The only curve that is real here is the average cost curve, and that is determined by the physical production constraint that exists out there. Now, the important question is that which of these hypothetical scenarios is going to materialize? Which of these isoprofit curves is actually going to happen? And that depends on the customer side, the demand side. So let's scroll down and add the demand to our model. So we go to 7.5, setting price and quantity to maximize profit. If you scroll down, you see that we have added the demand curve to our model. In this case, the entrepreneur finds the point where the demand meets the highest profit scenario. In other words, the demand curve becomes tangential to the highest isoprofit curve. And that is represented by point E. In this case, Beautiful Cars were charged around $5,000 for each of their car, and they end up producing 32 cars per day. And in total, they make a profit of $63,360 per day. Now, it's important to stress that the Beautiful Car Company finds this price and quantity by trial and error. For instance, let's assume at the beginning, they produce the same quantity of cars, 32, but they charge $4,000. What's going to happen? People are going to rush to buy these cars, and they find themselves that there are a lot of other people that want to buy their cars. So there is an unmet demand at this price. So they can think of two options: either increasing their quantity to make more profit, or they produce the same quantity and charge more for their cars. Let's assume that they go for the second option. They still produce the same amount of cars, 32, but they increase their price from around $4,000 to $5,000. In this case, they increase their profit from $33,000 per day to $63,000 per day. Now, seeing this, Beautiful Car might think that we can actually further increase our profit by further increasing our price. Let's assume that they decide to charge $7,000 for their car. So they end up here. What's going to happen? They're going to find out that not all of their cars is going to sell in this scenario. There's not enough demand for their cars when they price their cars around $7,000. So what's going to happen? They're going to go back and reduce their price, and eventually they're going to settle at point E. Let me add that at point E, the slope of a demand curve, that is the marginal rate of transformation, is equal to the slope of the isoprofit curve, that is the marginal rate of substitution. Sounds familiar? This is the same kind of an economic problem that we encountered in our previous units, and we called it constraint maximization problem. This is the case where the willingness of someone matches the constraint that exists out there, and that represents the best possible scenario.